Hello everyone, my name is Jassal and I will be presenting on my midterm project for DATS 6202 Machine Learning 1 with Professor G. The title of my project is How Much is Your Hospital Charging and How Much Are They Getting Paid? So this is the outline of my project. It's a combination of PowerPoint as well as Python code snippets. The goal was to not only answer the problem statement, but also demonstrate what I learned along the way. The purple is logistics, the blue is data analysis, and the green are my data models. So that's how I broke it up so far. As an introduction and background, there was a very famous Time article written by Stephen Brill in 2013. It highlights the inconsistencies of hospital charges and sometimes even within the same city. A charge master is a list of codes and prices used by a hospital and is used to initiate reimbursement payments from insurance companies, such as CMS, which is the biggest insurance company out there. The charge master system is widely unfavored, yet still widely used. I was most focused on high charges and then visually noticed they received high payments as well. In order to look at a standardized field, I divided the two numbers together to equal the C2P ratio. A high ratio is unfavorable because it means a hospital charged much more than they received, and those charges could trickle down to a patient. After studying the data, I was interested in three fields: discharges, charges, and payments, and came up with two problem statements. The first: does hospital size affect C2P ratio? As a proxy for hospital size, we're going to use the total discharges, which is in the bold column below. As the more, or another way to rephrase the question is, the more discharges, the larger the hospital. Number two problem statement: can we predict the C2P based on demographic of the hospital and the DRG? The DRG is a code for what you are charged. For example, number 870 is more severe septicemia compared to 871. Thus will be reimbursed at a higher rate. In the dataset below, we can see high C2P ratios with a high total discharges. They're highlighted in yellow. And this is also a sample of my dataset. Next is the data dictionary. I'm not going to read every single column, but there were 12 columns, and they all have obviously a definition. This is a government data source, so it's pretty clean definitions. Now we're going to start the code section of the presentation. While I would not show this much code in a real business presentation, I thought the audience here would enjoy reading my code while I discussed it. In the data tidying section, I renamed the columns, removed extra characters, changed the data format, created a C2P ratio column, and also checked for nulls. I like to use the shape, dtypes, and describe functions after I'm done to summarize my work and also to check my work. You can see the output of those functions on the right. Next, I removed outliers. The definition of the outlier is if any of the float features had a z-score greater than 2. This removed about 27,000 rows, or about 16% of my data. I also scaled my data using the min-max scaler method. This changed the float features to a range between 0 and 1. You can see the output on the right. I used matplotlib package and specifically the subplot and hist functions to create distributions of my float features. As you can tell, all the distributions are right skewed. Next, I created a pairwise plot that compared multiple features at the same time. The diagonal is the same plot as the last slide. The scatter plots, which are in indigo, were not as useful because it's hard to tell density, thus difficult to determine if the correlation is positive or negative. I created these plots to answer the first problem statement. Does hospital size affect C2P ratio? I realized without a trend line, it was difficult to assume correlation, just like we had in the previous slide. So from the individual points on the right side of the graph, we can assume that it's a negative slope, but I really wanted to make sure. Also, both graphs are exactly the same, but have different axes, or axes. The top one is unscaled, while the bottom one is scaled. This was to check if my min-max scaler worked correctly, and obviously it does. I recreated the last slide's plots using the Seaborn package, and then added a linear regression trend line. As you can tell, there is a slight increase, which is contrary to what we assumed in the previous slide. I also flipped the X and Y axis, so we can definitely say as total discharges increases, C2P ratio also increase. Remember, high C2P ratio or charge to payment ratio is unfavorable because those extra charges the hospital was not reimbursed for can see its way trickle down to the patient. Next, I performed a rather simple linear regression using 4 features. The Y variable is total discharges. The fourth coefficient or slope is 0.14, which is the correlation between C2P ratio and total discharges. And this is also observed on the previous slide. So this really demonstrates that scatter plots are important, visualizations are important, but also we did a linear regression, which is that cyan blue line. I also ran a stochastic gradient descent and received a positive coefficient for C2P ratio. It's also the fourth number, as observed in the previous 2 slides. So comparing the results of the LM and the SGD models, the LM model performed more favorably because it had a higher R-squared score, and they had both similar mean square error rates. We want mean square error rate to be low and the R-squared to be high. Next, I performed a KNN model in an attempt to answer problem statement number 2. And just as a recap, problem statement number 2 is, based on demographics, can we predict the charge to payment ratio? I first defined my X variables and then my Y variables, some notes about each. I realized I had to convert my X variables, which are strings, into a numeric format, thus used Panda's getDummies function. This transformation increased my column size from 1 to 306, which in turn made my model run very slow on my laptop. I originally had more than one X variable, but after I converted them to dummies, I only ran it with one variable. I also used a smaller data set, which was 25,000 randomly selected rows out of the original 136,000. This was also because of computation limitations. Next, I binned my C2P ratio, which was my Y variable, into 4 almost equal tiers. The binning frequency is on the right. It is pretty close. And this was so that it would increase the accuracy, but also make it a little bit more human readable and human usable. Finally, I partitioned the data and created an accuracy measure. I then went ahead and predicted the C2P ratio of Birmingham, Alabama, which predicts to have a C2P ratio of 3, which is also, the 3 is the bin, which is also between 0.14 and 0.2 ratio. While the model works, it is not very practical in a business setting. We will discuss roadblocks and feature steps next. So some roadblocks, the biggest one was computation power. My laptop could not handle such a large data set, especially running models, and some of the visualizations took a very long time as well. And the other one was the KNN model. The dummy variables really increased the number of columns, which went hand in hand with the computation problem issue. And Also, I should have added more bins rather than 4. I could have added maybe 8 or even more than that, just to make it a little bit more realistic of a model. And as for future steps, other variables affecting C2P ratio, I used total discharges because it was convenient in my data set, but in reality, I think it has to do more with profit versus unprofit hospitals. If you're in the Northern Virginia region, Reston Hospital, for example, is for profit, while Inova Health System is nonprofit. And I also could have done a logistic regression in addition to the KNN, and maybe try to predict whether or not C2P ratio would be greater than or less than a certain number. And yeah, those would be future steps that I would work on if I were to redo this project. So that is all for my project, and thank you very much.